Hello everyone and welcome back to Inside Sendium. I'm Dimitris Petrakis, Community Manager at Sendium, and today I'm joined by Manos Alefragkis from the development team. In this episode we're looking at routing, TPS and real-world messaging control, three areas that are critical when SMS infrastructure moves from theory to production. Now, we'll keep this high level but practical, how messages are routed, how throughput is managed, why control matters, and what technical teams need from a modern SMS gateway. Manos, welcome to Inside Sendium. It's good to have you with us. How are you?
Hi, Dimitri. I'm fine. I'm really glad to be invited here today in Inside Sendium. Third episode actually. As you said, I'm Manos Alefragkis. I'll take the lead and introduce myself. I'm the PO and product manager for MCore platform at Cytech. I hold a degree in computer science, and even though my background is purely technical, I am nowadays more focused on the business side of messaging. Let's put it that way. So for Sendium, I mostly work as an internal consultant, offering my experience and expertise in the field, and in order to, take decisions around product development and stuff.
Mm-hmm. Wonderful. All right, so since you took the lead and you introduced yourself, you got my first question over there. So I'm going to go straight to the point and ask you, when we talk about routing in an SMS gateway, what are we actually deciding?
As you said, routing is a set of decisions. So basically, as soon as a message is accepted by a gateway and forwarded to the routing, it's basically it becomes subject to the business and operational rules. So it translates into a delivery path. It translates the business and operational rule to delivery path. So what should happen next to a message, depending on its message attributes, like the customer account, the destination, the sender, the message type, priority, encoding, etc. And of course, choosing an outbound provider to terminate the traffic in the end. But that's the end of the route.
Mm-hmm. Okay. TPS is a term people in messaging use all the time. Now, how would you explain TPS to someone who understands software but is not, deep into telecom?
TPS is the acronym that you're hearing mostly in the messaging area, and it is basically one of the well-known acronyms that everyone follows. So TPS means transactions per second in simple terms, and it describes the rate at which messaging traffic is allowed to move through a connection or a route. But it's not just a speed metric. Usually the providers impose TPS limits in order to not exceed or not create thresholds on their side and not create throttling, etc. So not adding a TPS on our side, on Sendium side or customers of Sendium, it's basically a root cause to throttling and rejecting requests. At the same time, setting a TPS too low could create queues and delivery delay. So TPS is therefore a control for predictable behavior and capacity planning, not a promise that the same number of messages will be delivered every second through the platform itself.
Okay, all right. And how do routing decisions and TPS limits interact in real-world SMS traffic?
Routing decides which path receives the traffic, and that path has its own capacity and throughput policy. For example, one provider may be limited to 50 TPS, while another has a different limit. If messages arrive faster than the selected route can process them, the excess traffic waits and the latency grows. So it grows the queues, as we used to call them. So the good control of the matching routing policy with the route capacity keeps the busy provider always below the limit, and of course enables a second alternative to go into live traffic and basically serve the rest of our traffic, the rest of our messages.
Mm-hmm. Okay. And Manos, I'd like to ask you, what makes real-world messaging control difficult compared to a clean demo environment?
The demo environment is usually the happy path. So everything is, organized. Everything is well thought, and so you have one or a couple of messages, basically a number of messages. You have a couple of routes, again tested, etc. You have a healthy provider, usually a provider that imitates your own system, and so the interconnection process. Sendings, the submissions of SMSs and delivery reports are all going well. Whereas in a production environment, anything could possibly go wrong. So different kind of errors, connection drop, delivery receipts that may arrive much later than anticipated. So the difficult part is not processing one message. It is keeping the behavior controlled and understandable whilst all of those conditions interact with each other.
Yeah, you mentioned before that the demo environment is where everything is clean and nice and beautiful and wonderful, because that's exactly what it is. It's a demo environment, right? Well, I guess in production environments, things are a little bit different. They must be quite more messy, quite more dynamic. It's the real warfield over there. So this is where you actually get battle tested, right?
That's correct. This is where you're getting battle tested, and this is basically where you see the real different approaches in terms of implementation, different approaches in terms of configuration of each worker, of its provider, and that ends up to most of the times like hours or days of configuration before you will be able to actually accept and deliver production traffic.
I see. And in SMS operations, routes may slow down, connections may drop, or providers may have may behave differently. So, how should a gateway be designed with with that reality in mind?
Basically, a gateway should assume that the worst case scenario will happen. It's where we start from designing a gateway. So you should anticipate the connections to drop. You should anticipate the providers to occasionally slow down or reject the traffic for numerous reasons, because you terminate some cooperation, some partnership with some provider. You're losing some traffic because of firewalls. You're losing some traffic because of destination not working or changing regulations, etc. So that's dynamic. So you should take into account that all things might go south, and at the same point, you need to distinguish which of them are temporary issues and which of them are like longer-standing issues that you may face. So, for instance, you could identify a loop that is keep happening for a provider. You could identify some minor reconnection that needs to be done in order to restore a connection, some minor retry scheme like in a message because something went wrong, but just instantly, and that's how it works, basically.
Mm-hmm. We keep hearing from the Sendium team that everything shouldn't be a black box, and so here comes the question: why is visibility so important for teams that operate SMS infrastructure?
Look, when a customer asks what happened to a message, the operator or the administrator of a gateway needs more than a simple success or failure result. So they need to understand whether it was accepted, the message has been sent, where it was routed, whether it waited, like on a queue or something, what the provider returned, whether it was retried, and whether a delivery receipt arrived in time or not. Mm-hmm. So without that kind of visibility, routing becomes a black box, and incidents turn into guesswork. So visibility is what allows teams to operate the gateway with confidence and explain the behavior to customers, basically.
All right. And Manos, I would like to ask you, how does Sendium approach the idea of giving teams more control over routing and messaging behavior?
Yeah, Sendium keeps routing policy explicit through ordered file-based rules and routing chains. So teams can route using message and account attribute, as I said before, while outbound workers, like providers, can have their own queues, their own TPS spacing, their retry behavior, their SMTP connections, etc. So it's routing basically changes can be reloaded while the gateway is running. So they take place on the fly, and this gives the operators the control over how different traffic use different kind of providers without hiding the decision inside the closed platform.
Mm-hmm. And if a developer or technical team is exploring Sendium after this episode, what should they look at first?
Of course, I would start with README, Docker Quick Start, documentation, map the follow to SMTP, routing, HTTP API, and troubleshooting guides. Swagger, OpenAI, and OpenAPI help with the HTTP interface. Teams migrating from Canal can also try the browser-based converter as a starting assistant while reviewing, the generated configuration before production use, of course, and with caution. The best next step is to reproduce one real but bounded message flow in a test environment, and then start working on production, of course. But for us, the most valuable feedback is use the environment, come up with some issues, report them back to us through GitHub discussions, etc., and try to keep them reproducible in order to allow us, to step in and help the teams out.
Wonderful. And I think this is also a good opportunity to remind everybody that, they can visit our GitHub community. So we will place the link beneath this video on the description, so you can find the GitHub community and start interacting with others, and tell us also what you think. So Manos, thank you very much for joining this episode of Inside Sendium. Today we looked at routing, TPS and real-world messaging control, not as abstract technical terms, but as core parts of reliable SMS infrastructure. For everyone watching, Sendium is open source. You can explore the project on GitHub, as I just said, read the documentation, test it, and join the conversation. This was Inside Sendium. We'll be back in 2 weeks with another short conversation from behind the project. Thank you for watching.
Thank you. Cheers.